Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to discuss a very important thing, that is your model question paper number 1. So PU2 model question paper, there are 3 different model question papers published by your PU board this year, and as you are aware that all the 3 model paper have slightly different blueprint for each and every one. I have discussed all the blueprints in a separate video, you can check that out, and also the number of questions is reduced. Previously I think it was 48 or 50 questions, now the total number of questions is 45. So they have reduced few options that you might get in the answering section, right? So as they are trying to plug the gap that was there in the previous year, because many students complained that many questions are not part of the blueprint. Some questions are maybe slightly difficult out of the syllabus, even though none of the questions was out of the syllabus. Yes, there was some discrepancies, some fluctuations from the given blueprint. So that's why they have decided, okay, no more drama, I am giving you 3 blueprints, okay, and any one of the blueprint might come, and that is why they have reduced all the loopholes that they might have. So what we will do, we will try to solve the first model paper today, and we will solve the other model papers in our upcoming days. So all the 3 blueprints, all the 3 model papers will be solved in our channel, so don't go anywhere. And if you are first time in this channel, don't forget to subscribe to our channel, right? So let's start with the MCQ portions first. Most students struggle in the MCQ sections. So as usual, there will be 15 MCQ questions. Let's see one by one. The SI unit of electric charge is coulomb meter, coulomb per meter, coulomb per coulomb. Okay, what is the question? SI unit of charge density, SI unit of surface charge density. Oh no, it is only electric charge. It's not charge density. What is the unit of electric charge? Obviously coulomb. As simple as that. So simple. People say that MCQs are tumba hard. It is not hard. It's very easy, right? Next is the angle between the equipotential surface and the electric potential. So if this is the electric equipotential surface and electric field. So this is the equipotential surface, electric field will be always 90 degrees. So correct answer is 90 degrees. Now next question, statement 1, the resistivity of metals increases with increase in temperature. Resistivity means rho, so rho actually increases with increase in temperature. Yes, this is the correct statement. Increasing the temperature of the metal causes more frequent collision of the electrons. So electrons which is present in the metal, they help to carry the electric field, so that is why current flows from one point to another, right? So they are reacting to the applied electric field, that is why current flows. Now as you increase the temperature, the electrons are gaining energy, and gaining the energy, that means they are now colliding with each other. More collision means less electrons are passing, so less electron passing means resistivity increases. Yes, statement 2 is also correct, and it is the correct explanation for statement 1. So this is where students make mistakes because they are not able to relate whether the both statements are correct, whether the statement 2 is the correct explanation of the 2 or 1 or not. So this is where student makes mistakes. So that is why you have to practice such questions, statement based questions. That is very important, because at least one statement based question will come in your PU board final. Okay, both 1 and 2 are true, and 2 is the correct explanation as 1. So option A is correct answer. Next is a moving coil galvanometer can be converted into voltmeter by connecting. So you are converting a galvanometer into voltmeter. We know that we have to connect a high resistance in series to convert it into a voltmeter. This can be converted into a voltmeter by adding a high resistance in series. So a high resistance in series with the galvanometer is required to convert it into a voltmeter. So correct answer is option D. You know the answer, you have to check or read the options and find the correct option as soon as you can find it. Next question number 5. When a bar magnet is suspended freely, it points in the direction of east-west, north-south, northeast, southeast, northwest, southwest. Is it a question? This is not a question. This is just a very easy question. North-south. When you suspend a magnet, it always points towards the north and south direction. Right? As easy as this. The energy stored in an inductor of inductance L in establishing a current I in it. So now here they have not mentioned AC. So be careful. If this is in AC, the answer would be 0. But here it is not AC. It is just establishing the current I. So answer is half Li square. If the same question was asked, a inductor, what is the power? What is the energy stored in a inductor? What is the power dissipated in an inductor? The answer would be 0 if it is connected in an AC circuit. Okay, be careful. Here it is energy stored in an inductor. It is half Li square. Now, the direction of current induced in the loop ABC as shown in the figure. This was a very old KCET question. So they have recycled this question for PU board now. So current is flowing in this direction. Okay, and you have to find the induced current due to this coil. So first of all, when the current is flowing in this wire, what is the magnetic field produced by this current? So the magnetic field produced by this current is into the page of the paper. So you know the right hand rule. So you have to put your fingers in the direction of paper, direction of current, and then you have to point your fingers towards it, or someone say that if this is the current, then whatever direction your palm points at, that is the direction of magnetic field. So that is also palm rule. So palm rule means this is the current, so magnetic field will be into the paper. So into the paper means this is the direction of magnetic field. This is the magnetic field due to this current. Right, this is the magnetic field due to this current. Now this magnetic field will try to induce a current on this loop. Right, there is a circular loop, so there will be an induced current. Now what will be the induced current? The induced current will be such that it opposes the magnetic field. So the opposes the magnetic field means it will be the magnetic field will be in the opposite direction. The original magnetic field into the paper. Original magnetic field is into the paper, so the induced magnetic field will be out of the paper. So out of the paper means it will be flowing, the current will be in this direction, right? So ACB or BAC, whatever you consider. So the induced current will be in this direction. Okay, so that you get a magnetic field out of the paper. Okay, this is a very high level question, not super simple, as you can see. So along ABC if it is increasing, along ABC if it is decreasing. Okay, both cases are given. So increasing, decreasing, both are given. So it will be along this direction if current is increasing. Okay, so if current is increasing, then it will be along this direction. Okay, current increasing means it is increasing, so it will try to oppose the current. Now if it is decreasing, so if it is decreasing, then it will be a different answer. If it is decreasing, then the current will be in this direction. So blue line signifies the current decreasing. So current decreasing means it will be again into the same direction of the magnetic field, because decreasing magnetic field gives rise to the induced magnetic field will try to increase the field. So it will be in the direction of A, B, C if the current in the wire is decreasing. If the current I is decreasing, then it will be along ABC. This is the correct answer. Okay, it will be along ACB if the I is increasing. This is also correct. So many student gets confused with this answer. Let's see once more. If this is the original current and due to this there is an existing magnetic field, now you have placed this coil and now there will be some induced current passing through this coil based on whether the current is increasing or current is decreasing. If the current is constant, no change will happen. So first of all, we have found out that if current is increasing, so if current is increasing, then the induced current induced current will try to oppose this already existing magnetic field. Keep this in your mind. There are a lot of explanations available in internet. I have seen that, and many of them are actually try to complicate the things. First of all, you have to find the original magnetic field due to this current. So current is passing through this, so the original magnetic field in this part of the wire will be into the page of the paper, right? Clear about that. So you have to put your fingers like that and put your thumb in the direction of current, and your other fingers will point towards the direction of magnetic field. I hope you are familiar with this. So from this we have found out the original magnetic field is into the paper. Now if current is increasing, then the induced current will oppose this magnetic field. So current will be flowing in the direction so that the current opposes this magnetic field. So basically induced current will be like this in the red arrow, right? The red arrow signifies the motion of the current, right? So this is the outward direction, so it will be in the ACB direction if the current is increasing. Okay, so it will be along the ACB direction if the current is increasing. So option C is correct. Okay, and if the current is decreasing, then if the current is decreasing, that means magnetic field is decreasing, then the induced current will be in the same direction of the original field. So in that case it will be in the ABC direction. So in this question, in the blueprint, both options are correct. Okay, B and C are correct, but there is a mistake from their side, because in the they have copied somewhat copied this question from KCET exam. As I said, in the old KCET exam this was a question. Now that diagram was slightly different, the options was slightly different. While typing it from the KCET paper, whoever typed this question, they typed it incorrect. That is why option B and option C both are correct. There are many solution key, answer key available in internet, and they are giving you completely incorrect answer. Okay, there are few correct answers as well, but many of them are giving you incorrect answer. Even I have seen one paper key, they are saying along ABC if I is increasing, which is completely wrong. Okay, so be careful of such answer keys. If you are following our channel, we will always give you the correct answer. Okay, so this is, both of the options are correct for this particular question, but be sure that in the final exam there will be no such questions which will have both correct answer. Obviously this is done by only a few group of teachers, and they give it to some typewriter, so they type it, right? They have done some mistakes and it was not properly reviewed. But when the final paper comes, there are a lot of teachers, there is at least a very experienced, educated, well experienced teachers are sitting there in the panel. They will review your answer thoroughly, right? So don't worry about it. Now next question, an ideal step-up transformer decreases ideal step-up transformer. Step-up transformer means it is original purpose of a transformer is to change the voltage, right? Either it will increase the voltage or it will decrease the voltage. So if it is decreasing the voltage, we say step-down transformer. If it is increasing the voltage, we say step-up transformer. Now in this case, step-up transformer means it is increasing the voltage. Now if the voltage increases, the other thing which decreases is only the current. Okay, now for an ideal transformer, power remains constant, frequency remains constant, voltage will increase, so current will definitely decrease. So the answer for this question is current. Now question number 9, the displacement current is due to flow of electrons, flow of protons, changing electric field, changing magnetic field. So the displacement current is basically due to we know that the relationship between displacement current and electric field is that when the electric field is changing, as the electric field changing, the current will also change. So basically it is due to the changing electric field. Changing magnetic field is the induced current, not the displacement current. Displacement current is between the capacitor plates. If you have read the electromagnetic wave chapter, there we have seen that when the magnetic electric field changes, there is a current induced, that is called displacement current. So it is due to the changing electric field. Now, an object of finite height is placed in front of a concave mirror within its focus. It forms a enlarged image. So first of all, let us understand the question. We have a concave mirror, Okay, this is the focal length, and we have placed an object in front of within the focus. Within the focus means between the pole and the focus. Okay, so definitely it will produce a virtual and enlarged image, right? We know that a concave mirror produces virtual image when the distance is less than focal length, right? Convex mirror on the other hand always produce virtual images, and that is diminished. But in case of convex mirror, when the distance is less than focal length, it produces a enlarged image, virtual and erect. So it will be a virtual enlarged image. So virtual, enlarged and erect image. If they had one more option, they could have added it, but it is not there. So virtual and enlarged image is the correct answer for this question. Next question, a beam of unpolarized light of intensity I0, it is passed through a pair of Polaroids with their pass axis inclined at an angle of theta. The intensity of the emergent light is equal to. Very interesting question. So first we have a Polaroid, right? There is a Polaroid 1, there is a Polaroid 2. Okay, now they are not parallel, there is an angle between them. So let me correct this one, just give me a second, let me correct this one. So they are not parallel, they have some angle between them. So this angle is theta. Okay, so there is an unpolarized light generally represented like this. Okay, this is the representation of an unpolarized light. Now once it passes through this Polaroid, it becomes polarized. Okay, now it becomes polarized. Now what is the intensity of this? So this intensity was I0. Okay, so after it passes through the first Polaroid, the intensity becomes half. So it will be I0 by 2. Okay, now when it passes through the second Polaroid, the intensity of this light becomes I0 by 2 cos square theta. This is Malus law. Okay, this is Malus law, so you have to remember this. It will be I0 by 2 cos square theta. So answer is D. Very, very careful. Many students blindly will answer I0 cos square theta. That is not correct. This is a trick that when unpolarized light passes through a Polaroid first, then the intensity drops to half. Then after that, when it passes through any other Polaroid, then Malus law applies. So if you read the Malus law, it says that any polarized light of intensity I0. So if the light is already polarized with an intensity I0, then it is I0 cos square theta. But here the intensity of the polarized light is I0 by 2. So you have to be careful to answer this type of questions. This is a very trappy question. So even though the answer is easy, but it is a very trappy question. Emission of electrons from a metal surface by heating is called, so emission of electron by heating a surface is called thermoionic emission. Okay, thermoionic emission. So that is the name for this. I think the spelling is thermionic emission. I think spelling is slightly incorrect. Thermoionic emission is when you are heating a metal and it is giving you electron. Okay, if you are applying electric field and it is emitting, then it is called field emission, and if it is due to light, then it is called photo emission. Okay, photoelectric emission or photo emission. Okay, secondary emission, I don't know there is any term called secondary emission. This is just a bogus option. Now question number 13, when alpha particles are passed through a thin gold foil, most of them go undeviated. So when alpha particles are passing through a thin gold foil, most of the particles are going undeviated because most of the region in an atom is empty space. Yes, so most of the region in the atom is empty space. So we know that atom is basically, this is a gold foil atom, suppose this is an atom, so most space in the atom are empty space. We have some electrons orbiting, but the entire mass is located here and most of the space are empty space. So when an alpha particle is going, it is going like this, and it is so only few of them are getting deviated, which are actually going towards it. So they are getting deviated, some are deviated little, but most most of the particle which is passing through this empty space, so it is not getting deviated. So that means if you are passing, you are throwing, I gave you an example, you are throwing ball towards a wall. If the wall is hollow, most of the part is wall is hollow, then the most of the balls will pass. But if the wall is solid, 90% of the ball, 99% of the balls will come back, right? So basically because the most part is hollow, that's why you are getting they are getting passed through. Okay, now nuclei with same atomic number is called isotopes. Nuclei with same atomic number means they are the same nucleus, same element, sorry, they are the same element, that means they are isotopes. Okay, now let's see a matching question. The column 1 of the list of the material and the column 2 is the list of the energy band gaps, e.g. identify the correct match. So we know that any band gap which is 0 or close to 0, they are conductor. So conductor is basically when Eg is equal to 0, right? So conductor is basically band gap is 0, and insulators is higher band gap, so their electron cannot jump from conduction band to valence band, so definitely it will be higher, so it will be definitely higher than 3 electron volt. Whereas semiconductors, they are basically in between conductor and insulator, so they are less than 3 electron volt, which can come down to 0 in certain suitable condition. Okay, and they can behave like a conductor. So answer is 1B, 2A, 3C. No, sorry, 1B, 2C, 3A. Okay, so 1B, let's see, 1B, both of them as 1B, so either one of them. Next is 2C. 2C is this one. Okay, so this one is the correct answer, 1B, 2C, 3A, right? So you can either, you have to match any two of them to get the correct match, right? All three variations are not generally possible, so if you get two matches correctly, mostly it will be correct answer. Okay, that is one of the trick that I am teaching you. Now let's see the fill in the blanks. Photon, polar, zero, infinite phase, phasor. A molecule possessing a permanent dipole moment is called polar, right? It's called a polar molecule. The net magnetic flux through any closed surface, it is not infinity, it is 0. Okay, that is Gauss's law of magnetism. Net magnetic flux through any closed surface is 0. A rotating vector used to represent the alternating quantities is called, phasor. Phasor, very careful, phasor. A wavefront is a surface of constant phase. Wavefront is a constant surface of phase. And in interaction with the matter, light behaves as if it is made up of packet of energy called photon. It is called photon. Okay, easy question. Only phasor and phase may be slightly confusing, otherwise all the other answers are straightforward. Now let's move on to the 2 marker section. State and explain the Gauss's law in electrostatics. So Gauss's law states that the total electric flux passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. So explanation is phi net equals to Q enclosed by epsilon naught. Now you have to show some charges, Q enclosed, and this is the surface. Okay, this is surface, the phi, this is the phi net. Okay, so total flux coming out of a closed surface is basically given by total charge enclosed in the by the surface divided by epsilon naught. This is the explanation. Simple question, very simple question. You have to draw this diagram and explain this, mention this formula. That is sufficient. Now let's move on to the next question. Define drift velocity and mobility of free electrons in conductors. So drift velocity, the average velocity with which the free electrons drift under the influence of an electric field is called the drift velocity. So average velocity with which free electrons drift means, if you have played that game when I was a kid, I used to do that. We used to make that small paper boats and then we put it into the rainwater. So the paper boats used to move along the direction of the rainwater, right? So that motion is called drifting. It moves due to along with the force, along with the motion of the water, right? So since like that electrons move in the direction, opposite direction of the electric field, this is called drifting. The mobility of free electron is unit is meter per second. Very interesting. It is same as the speed. Okay, the mobility of free electron is defined as the drift velocity of electron per unit electric field applied. So drift velocity of electron per unit electric field applied, and its unit is meter square per second per volt inverse, or meter per second Newton inverse coulomb. Okay, so Newton per coulomb is the electric field and meter per second is the drift velocity. So mobility is basically drift velocity divided by electric field. Okay, so this is another definition. Okay, now let's move on. A long air core solenoid of 1000 tons per unit length carries a current of 2 ampere. Calculate the magnetic field at the midpoint on its axis. So there is a long solenoid carrying some current, number of tons per unit length is 1000. So what is the magnetic field at the center? Okay, so magnetic field for a solenoid we know that is given by mu naught Ni. Okay, so mu naught is 4 pi into 10 to the power of minus 7. N is given 1000 and current is given 2 ampere. So this is the magnetic field. So answer will be Tesla, in Tesla. Okay, now multiply 2 into 4 is 8 pi into 10 to the power of minus 1, 2, 3. 3 minus 7 plus 3 is minus 4. So 8 pi into 10 to the power of minus 4 Tesla. As easy as that. You can use a calculator to find the value. Otherwise, if you leave it here, you will get full marks. Only thing you have to mention that the magnetic field inside a solenoid is given by, okay, B is equal to mu naught Ni. As simple as that. If you do it, you will get full marks. Now question number 24. Give the principle of AC generator. Why is a current induced in an AC generator is called alternating current? Let's see the answer quickly. An AC generator converts mechanical energy into electrical energy by changing the flux linked with the rotating coil. The direction of the current produced in an AC generator changes periodically, and therefore the current is called alternating current AC. So this is simple. So AC generator basically works in the principle mechanical energy converted into electrical energy. So that is why it is called generator. Generator means generate, and the current that is generated in AC generator, they are basically changing their direction with every passing second. That's why this is called alternating current. As simple as a very simple answer. Now next move on. Write any two uses of ultraviolet radiations. Another simple question. UV radiation can be focused into very narrow beams for high precision applications such as LASIK. LASIK is nothing but laser eye operation. So if you are suffering from some eye defect and you want to do some operation, LASIK is one of the option. Next is UV lamps are used to kill germs in water purifiers. If you have a water purifier in your home, you know that there is a UV lamp. People call it UV lamp. Okay, UV lamp is basically a device which can kill germs present in the water. Okay, UV filter, if you have heard the name UV filter. UV filter means it's just a UV lamp which is killing the germs present in the water. Next, question number 26. Name the objective used in the refracting type of telescopes and reflecting type of telescope. So in the refracting type of telescope, convex lens is used. In reflecting type of telescope, concave mirror is used. What is the objective? Objective means from where the light falls the first time. Okay, so there may be some other arrangement as well. So when the light, whoever is gathering the light for the first time is called the objective. In case of concave mirror is the objective, for reflecting telescope, and for refracting telescope obviously we use convex mirror. Generally all the mirrors in eyepiece also we use convex mirror for refracting telescope, but in case of concave mirror there are different arrangement. Okay, now let's see the next part. Write two conditions for the total internal reflection to occur. Okay, I think this is a 2-mark question. Somehow it is mistaken. It will be a 2-mark question. Okay, what are the conditions? Light must travel from denser to rarer medium. The angle of incidence must be greater than that of the critical angle between the medium, right? So this is the answer. Now next question, name the majority and minority charge carriers in an n-type semiconductor. N means negative type, right? So negative type means majority will be electrons, minority will be holes. As simple as that. You have to identify n-type means in negative type. Again, this is a 2-mark question. Somehow some of the 2-mark questions are unfortunately marked as 3 marks. Okay, so this is also a 2-mark question. So majority is electrons, minority are holes. Now write any 3 properties of electric field lines. This is a 3-mark question. Let's see another easy question, common question. So I think there is a mistake here. So this is not electric field lines, this is the properties of charges. This answer is incorrect. Okay, electric field line properties, we know that 2 electric field lines never intersect. Then we also know that electric field line starts at positive charge, ends at negative charge or at infinity. Okay, similarly higher number of electric field lines represents higher electric field, higher strength, stronger magnetic electric field, whereas less number of field lines represents weaker electric field. Okay, so these are the very 3 basic properties of electric field lines. You can find the answer. I have discussed this multiple times and very easy question. So even though by mistake there are properties of charges are written, but not is electric field lines are also very easy. Right, now obtain an expression for the effective capacitance of 2 capacitors connected in parallel. So I think this is a 3-mark question. Again some mismatch happened. This is a 3-mark question. We also know this is a very easy part. So 2 capacitors connected in parallel. So what is the meaning of parallel means? Okay, so here we have 2 capacitors, say C1, C2 connected in parallel with the battery, say V. Okay, what is the thing that is constant in parallel? And if you draw an equivalent circuit of this, then there will be only one capacitor and the same battery. Okay, same battery, C equivalent, and the same battery V. Okay, now when I say equivalent capacitance, what is the meaning of that? Equivalent capacitance means I can replace these 2 capacitors with a single capacitor, but everything in the circuit will remain the same. So suppose initially total charge flowing in the circuit was Q, the same charge will flow in the circuit again. Okay, nothing will change, only the 2 capacitors will be replaced by 1 capacitor. That is called equivalent capacitance. Basically now series and parallel, they behave differently. In case of series capacitor, charge through all the capacitors are same. In case of parallel capacitors, voltage across each capacitors are same because they are connected in parallel. So you can consider this is a path, independent path. This path is independent from the below path, right? Both are separate paths. Separate path means individually both the capacitors are getting the same voltage, right? Now if the charge through this one, say Q1, and if the charge through this one is Q2, okay, then from the conservation of charge we can say Q is equal to Q1 plus Q2. right? Charges cannot be created or destroyed, so definitely whatever the total charge. Now remember that in case of resistance you have to use current, but in case of capacitor you have to use charge. Now since voltage is same for both capacitors, what we can write is that Q1 is basically C1V, okay, and Q2 is equal to C2V. Similarly, from the series capacitor, the equivalent capacitors, we can write Q is equal to C equivalent into V. Very simple. Okay, this is for capacitor 1, capacitor 2, this is for C equivalent. So total we can write, we can put these values here, C equivalent into V equals to C1 into V plus C2 into V. Now you can take V common, so C equivalent is equal to C1 plus C2, right? This is the derivation, simple easy derivation, that's why 3 marks. Now let's move on to the next part. What is Lorentz force? Another 3 marks question. Okay, what is Lorentz force? Okay, Lorentz force is the force between magnetic field when a charge is moving through an electric and magnetic field, the total or the net force experienced by the charge is called Lorentz force, right? What is the expression? Lorentz force is given by F equals to Q common electric field E plus V cross B, right? Q is the charge, E is electric field, B is magnetic field, V is velocity of the charge, right? So this is you have to write it in full. I just write it in shortcut so that I don't waste too much time on this. This is an easy question. So Lorentz force is very, very, very important from this chapter, moving charges and magnetism. MCQ question, 2 mark question, 3 mark question, all sorts of question will come from this concept only. Okay, so now write 3 differences between diamagnetic and paramagnetic substance. Again another 3 mark question. Okay, let's see the answer. So diamagnetic and paramagnetic magnetic behavior, these are weakly repelled by magnetic field. Paramagnet, they are weakly attracted by magnetic field. Magnetic susceptibility have small negative magnetic susceptibility chi less than 0, have small positive magnetic susceptibility chi greater than 0. Effect in a magnetic field induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction as the applied field. Now this is corrected. Describe an experiment to demonstrate the phenomenon of electromagnetic induction using a bar magnet and a coil. Let's see the experiment. So when a bar magnet approaches the coil, the galvanometer needle deflects, indicating a current is induced. When the magnet is pulled away, the needle deflects the opposite direction, showing that the current reverses. No current is induced when the magnet is stationary related to the coil. So this much answer along with this should be sufficient, but if you want you can add this conclusion as well. Maybe sometimes a teacher wants something more, so this is the part where you have to mention that. Okay. There they have only mentioned that demonstrate, explain the experiment. They have not mentioned any conclusion, but I have given this voluntarily. This experiment demonstrate electromagnetic induction. A current is induced in the coil when the magnetic flux through the coil changes. This confirms Faraday's law of induction, and the direction of the current follows Lentz's law opposing the charge in the magnetic flux, right? Give any 3 results of the experimental study of the photoelectric effect. So let's see. This is the same question as Hallward-Leonard experiment, observation by Hallward-Leonard, interpretation of Hallward-Leonard. Same question is this: for a given metal, no electrons are emitted if the frequency of the incident light is below a certain minimum value, called the threshold frequency nu naught, regardless of the intensity of the light. Photoelectron emission occurs without any noticeable delay after the light strikes the surface, even for very low light intensities, right? Maximum kinetic energy of the emitted electron increases linearly with the frequency of the incident light above the threshold frequency. Easy question. Let's move on to the last question, I think, of the 3-mark series. Write the 3 postulates of Bohr's atomic model. Another very common question. I have seen this question multiple times in your pre-board series, right? So most expected question. Bohr model is applicable to hydrogenic atoms. It cannot be extended even mere to 2 electron atoms such as helium. While Bohr atomic model correctly predicts the frequencies of the light emitted by hydrogenic atoms, the model is unable to explain. I think this is the drawback of the Bohr atomic model, not the postulates. Postulates are like electrons are orbiting in the fixed. I will give you the PDF. While I give the PDF, I will correct these questions as well. Don't worry, there are 2 questions by mistake. There was answers were wrong, but I will give you the PDF with the correct solution. Don't worry about it. We will provide the PDF for all the blueprints. Once we solve one by one, I will give you the PDF. So what is the first point? Past postulate that electrons are orbiting in the stable orbit. Okay. Secondly, the orbital angular momentum is integral multiple of nh by 2 pi, right? That is the integral multiple of h by 2 pi, right? And electrons, when they jump from one orbit to another, they emit energy, and if they gain energy, they go to the higher energy state, and if they go from higher energy state to lower energy state, then they emit energy, they emit the excess energy, right? These are the main 3 postulates. You can write it down, okay? Otherwise, this is not the correct answer, okay? This is not the correct answer. This is the drawback of Bohr's atomic model, okay? Now let's move on. Find the energy equivalent of one atomic mass unit in joule MeV. This is also a 3-mark question. So we know that energy is basically given by mc square. E equals to mc square. What is m here? M is 1u. Now in this question also, in your blueprint, the 1u value was given 10 to the power of minus 2. Such a blind mistake they have made, okay? 1u is not 10 to the power of minus 2, it is 10 to the power of minus 27, okay? So 1u means 1 atomic unit, right? So 1 atomic mass unit, AMU or u, right? So what is m? M is 1.6605 into 10 to the power of minus 27 into c square. C, we know that c is 3 into 10 to the power 8, or whatever value they have given. If you use the exact value, you will get more correct answer. Anyway, does not matter. We know the answer, so we don't bother too much about these values, okay? Whole square. So this is the energy, right? This is the energy in joules. You can find whatever is the value of this in joules, applying the multiplier, okay? You have to square this term and then multiply 1.66 to calculate it in joules, because in joules also you will get 1 mark. Now to calculate in EV, what we have to do, we have to divide this entire term 1.6605 into 10 to the power of minus 27 into it will be approximately, if I remember correctly, it will be 1.49 into 10 to the power of minus 10, I think. Minus 10. This will be the answer, okay, in joules. Okay, So let me write that only. Let's not waste too much time. So 1.49 into 10 to the power of minus 10 divided by electron, charge of an electron. So that is 1.6 into 10 to the power of minus 19, which will come out to be 9315 into 10 to the power of minus 9, 10 to the power of plus 9, sorry, extremely sorry, plus 9, right? Minus 10, this will go up and it will become plus 10. So what we will take? We will take 3 of the zeros for my own use. So 931.5 into 10 to the power of 6 electron volt. Now 10 to the power of 6 can be written as 931.5 mega electron volt. Okay, this is the answer. This is a very common useful constant. If you are preparing for any competitive exam, you have to remember this value, right? I have told you multiple times. So this is the thing that you have to solve. Very easy question. Now next question. Derive the expression for the electric field at a point on the axis of an electric dipole. Let me quickly do it. I have done it multiple times. So this is a dipole. Which one I will take positive? Let's say this is negative, this is positive. Okay, we are trying to find the electric field at some point, say P. Okay, the distance between the P and the midpoint of the dipole is R. Okay, the length of the dipole is A. This is A, total length is 2A, right? Now electric field due to plus is in this direction, so this is E plus, and electric field due to negative charge is in this direction, this is E minus, right? This is the diagram. Now dipole moment is defined, it is from the negative to positive charge. So the dipole moment is given by 2qa, okay, or q into 2a. This is dipole moment, and direction is from negative to positive. This is the thing, we know that. Now let's find the electric field one by one. E plus is basically 1 by 4 pi epsilon naught charge divided by the distance. Distance in this case is this distance. What is this distance? This distance is total the midpoint. From the midpoint it is R. From the midpoint the distance is R. So from here it will be R minus A. So R minus A whole square. Okay, and E minus is 1 by 4 pi epsilon naught Q by R plus A whole square. So these are the two electric fields. So let's add them. Okay, now what is the direction of the electric field? Electric field E plus is in the direction or right side along the positive x-axis. So and negative electric field is the negative x-axis, is opposite direction. So even though we are adding them, the net electric field while calculating it, it will be subtracting, right? And if you notice that the P is from negative to positive, and the positive electric field is also in the direction of P. Now positive electric field not only in the direction of P, this is also bigger than negative electric field. So we will take this one first, 1 by 4 pi epsilon naught. This is common. What we will do, we will write Q by R minus A whole square minus Q by R plus A whole square, considering the direction. So we are adding here vectorially. So here it will be along the direction of x cap, you can say that. So now 1 by 4 pi epsilon naught. If you don't want to avoid vector, what you can do, you can simply, instead of doing that, you can add here negative sign. That's it. Okay, while calculating the electric field, never use sign of the charge. This is very, very important. While calculating the electric field, never use sign of the electric charge. Only thing that you have to use is the direction. If they are in the same direction, they will be added. If they are in the opposite direction, they will be subtracted. That's it. While calculating the magnetic electric potential, on the other hand, you have to use the symbol. of the charge, because that is a scalar quantity. This is a vector quantity, so q is also common. See, q is also common. Now let's see. So what is the this r plus a whole square minus r minus a whole square divided by r minus a in whole square into r plus a whole square, right? This is the simple thing, right, the way we do it. Now what we will do, we will simply square them, right? Now so q by 4 pi epsilon naught, so a plus b whole square minus a minus b whole square, that is 4ab, so 4ra divided by, so it here inside if you see a plus b into a minus b, so that is a square minus b square whole square, right? Now let me write it down here. So you have to practice this 2-3 times to solve it quickly. So net electric field is basically given by 4 R A into Q divided by 4 pi epsilon naught R square minus a square whole square. Now don't cut this 4, it will be helpful if you don't cut this 4s. Okay, so r, let's keep this r. What we will do, we will make this 2 into 2aq into r divided by 4 pi epsilon naught r minus a r square minus a square whole square, right? Now we know that r is very greater than a. Why so? Because the definition of electric dipole says that two equal and opposite charges separated by a very small distance. So in that case a is very small compared to r, so we can approximate this value to be, let me write it here, so E net is basically now 2aq is basically the dipole moment, so 2p r divided by 4 pi epsilon naught into r to the power 4. Why r to the power 4? If r is very greater than a, then r square minus a square nearly equal to only r square, right? This is a very small number, so you can ignore that term in terms of importance. Now one of this r will cancel, so you will get E net equals to 2p by 4 pi epsilon naught r cube. Now if you find the direction, so electric field and the dipole moment will be in the same direction. We have already seen that electric field is also in this direction, dipole moment is also in this direction. So this is the common derivation. Now you have to practice this derivation 2-3 times to master it. Now next question. Two cells of different EMFs and different internal resistances are connected in series. Derive the expression for effective EMF and effective internal resistance of the combination. We do not have too much time, so I have to move little faster, right? You don't want to sit here entire day to watch me solving the model question paper, right? So we have to solve it little quicker. So this is epsilon 1, this is epsilon 2, this is R1, this is R2. Okay, so this is the this is not my mistake. This will be the resistance, right? This will be the resistance R. What is the cells in series? Cells in series. Let me redraw this once more. So we have two cells in series. One cell is this, then another cell is this, and then they are connected with the resistance. Okay, so this is epsilon 1 R1, epsilon 2 R2. Now if we find a equivalent circuit, equivalent means we replace everything with only one. Okay, equivalent means we replace everything with only one. So this is epsilon equivalent, this is r small r equivalent, and we are trying to find this, and all the other things in the circuit will be constant. So if the current was I, same current I will pass again right now. Now question number 38. Two cells of different EMFs and different internal resistances are connected in series. So here we have two cells. We know that cells in series, basically they are asking to find the equivalent EMF and equivalent resistance for the combination, right? So how to do that? We have to first connect them. So this is epsilon 1 R1, epsilon 2 R2. Generally EMF is represented using not exactly V1 V2, that represents potential. So for EMFs we do it using epsilon, right? And the equivalent circuit, what is an equivalent circuit? Equivalent circuit, as I say, is basically everything will remain same, only instead of having multiple components we will have only one component. For example, here we had two EMFs, so total current say I, the current in the circuit will remain unchanged. Now instead of epsilon 1 and epsilon 2, we will have only one epsilon equivalent and R equivalent. This external resistance will remain as it is. So what we have to do, we have to find this is an equivalent circuit. So we have to find epsilon equivalent and R equivalent from this given value, right? So first what we have to do, we have to apply Kirchhoff's law and find whatever it is there. So they are connected in series, so we can write current through the resistance is IR. So IR plus, because all the resistances can be considered to be connected in series, we can say I small r1 plus I small r2 equals to epsilon 1 plus epsilon 2. Simple, very simple, right? Or we can say that IR is basically epsilon 1 plus epsilon 2 minus I R1 plus R2. This is the equation number 1. Okay, this is the potential, this is the terminal potential. This is called, this term IR is also called terminal potential. Okay, sometimes we represent the same equation using V, not required. Now for equivalent circuit, this is from the given circuit, from the given circuit. And remember that for this derivation, the both diagrams are compulsory. Okay, without drawing the diagram, if you try to solve, you will not get any marks. Be careful. This derivation is very simple. Now for the equivalent circuit, the current remains the same, right? That is the condition. So therefore what we can say is that, what is the current in this case? Current is IR, current is I basically, so voltage drop across R is IR, voltage drop across R equivalent is IR equivalent, then that should be equals to the potential, right? That is the Kirchhoff's loop rule or Kirchhoff's voltage rule, right? If you go in a loop, okay, if you are going in the direction of current, then definitely every voltage drop across every component, that should be equals to the total potential, right? Now IR equals to epsilon equivalent minus I Req. Now this is equation 2. Now we have to do a small comparison. What is the comparison? See, IR on our left hand side, both are equal in equation 1 and equation 2. But in equation 1, the potential or the EMF is given by epsilon 1 plus epsilon 2, whereas in this case it is given epsilon equivalent. So comparing 1 and 2, we can write epsilon equivalent is equal to epsilon 1 plus epsilon 2. And what else? See, here again minus I R1 plus R2, here minus I R equivalent. So again we can say R equivalent is equal to R1 plus R2. So this is the basic comparison, very easy derivation, and if you do it you will get 5 marks. Only thing that you have to remember, a small description is required, and you have to mention the variables epsilon 1 and epsilon 2, epsilon 1 and R1 and epsilon 2 comma R2 are connected in series. So this the description of the diagram is also important, because the derivation part is very simple and easy. Okay, mostly I have seen that coming as a 3-mark question, but they have given it as a 5-mark question in the model paper, which if that comes in your board exam, then you will be lucky. Okay, what I have seen most cases, parallel one is coming as a 5-mark question, because that is little tricky. Derive the expression for the magnetic field at the point on the axis of a circular current loop. Very important derivation. This is a very important derivation. Okay, this derivation. Okay, this one and the parallel. Obviously Kirchhoff's Wheatstone bridge is also there from this chapter. No, sorry, this is from magnetic moment, right? No. Anyway, from this chapter, force between two parallel current carrying wires, and this loop one is very important. Okay, most asked question, one of the most asked question. So we are trying to find magnetic field at this point P. So we have to consider a small element, say dl. The radius of the loop is capital R. Okay, the distance from the point is x, and if this temporary distance what we are drawing, okay, my drawing skill is not super good, you already know that, right? So without using scale it is difficult to join 2 points also, right? So what I will do some cheating. I will remove this point from here, and we will put this point on that, right? So this is point P. We are trying to find the magnetic field at this point. This distance, say R. Now if you apply Pythagoras theorem, you can see this is R, this is x, so small r definitely will be square root of capital R square plus x square. Okay, you can add everything in this diagram itself. That will save some time for you to write. Okay, now the current element is dl. If you consider the current element, you know that this is the element, right? This is the element. Now you are trying to find a point somewhere here on the axis. So it is on the axis somewhere here, and if you consider this is the element, then the line that you are joining, that line and the tangent, basically they are at 90-degree angle. Okay, they are perpendicular. So what you can do, you can say that okay, they are perpendicular, so this angle is 90-degree. Okay, now if this angle, the internal angle is phi, then the magnetic field will also make an angle phi with this. Okay, this is the thing that you have to remember. If the internal angle is phi, the magnetic field will be making an angle phi with this axis. So this is, say, x-axis, so it will make an angle phi with the x-axis. Now you can divide this into two components. So say this is the magnetic field dB. Okay, small component. Now you can make two components, one component along y-axis, say dB y, and another component along x-axis, say dB x, right? Now about this circular coil, the important thing is that if you consider a diametrically opposite point means you just need to construct the diameter and then the opposite point. This is, you don't need to draw, I'm just explaining it. Okay, I'm just trying to explain it so that any doubt that you might have will be cleared. So if you consider any diametrically opposite point, because of that whatever magnetic field you will have, that will be exactly opposite to that phi. This is phi, means this will be also phi, right angle triangle, right? So this will be also phi, and you will get a component which is exactly opposite to dby. Okay, so dby, if you are considering this is plus dby, this will be minus dby. So total component along y-axis will cancel each other. So total component along y-axis will be 0. Whereas if you consider this x component dbx and dbx both will be in the same positive x direction. So they will add up. So x component will add up, whereas y component will be deleted. right? So similarly we can say that if we consider a diametrical, you have to write that if you consider a diametrically opposite component, then only the y axis only y component will be cancelled and x component will remain. Okay, so we will only consider the x component. That is very, very important. Now what is dB? First we will write dB. From Biot-Savart's law, dB is equal to mu naught by 4 pi I dl sin theta by r square. Now we have already seen that theta is basically equals to 90 degrees. So theta is 90 degrees. Now many students and I have seen many students, they use same symbol theta and phi. Do not do that. Okay, that is technically incorrect. You cannot use same symbol for two different quantities, right? So you have to be careful. You cannot use same symbol for two different quantities. Here theta equals to 90 degree, not phi. Phi is not 90 degrees. Okay, so dB becomes mu naught by 4 pi I dl divided by r square plus x square. Okay, why so? Because small r square, small r is basically the distance between the element and the point. So element and the point is small r, which is square root of r square plus x square. So r square is capital R square plus x square, right? So this is from this Pythagoras theorem, and sin 90 is 1. So that's how we have written it. Now as we have found out that total component, out of all the components only x component remains, so we are only interested to calculate the dBx component. So dBx is equal to dB. What is dB component, x component? So this is the angle, this is the component, so this is an adjacent component. For adjacent component it becomes cos, right? Adjacent component is cos and the perpendicular component is sine, if you remember slightly about resolution of vectors, right? So dB cos phi, so we have to find the value of cos phi as well. So mu naught by 4 pi I dl r square plus x square into cos phi. Cos phi is what? So if you consider this is the cos phi, this is phi, that cos phi is basically base by hypotenuse. So base is your r, whatever adjacent side, that is your base. So this is your base, here r, and hypotenuse is this term. So r divided by small r is basically nothing but r square plus x square square root. So this is the term. So it will be mu naught by 4 pi I r by r square plus x square to the power 3 by 2, okay, into dl. Okay, so what I have done, I have taken this to be to the power half. Square root means to the power half. Here we have to the power 1. So to the power half, to the power 1, if you add them you will get 3 by 2, right? I hope you have already practiced this multiple times, this derivation. If you have not, you have to practice it at least 3 times to make it perfect. Right, now total component, total magnetic field Bx is basically integral of dVx. Right, dBx we have calculated, so total magnetic field is basically integration. So integration means, if you see, mu naught by 4 pi is constant. For this given configuration, current is constant. Current is the current that is flowing in this coil. Current is constant. Okay, the radius is constant. The distance is given already, so the distance is also constant. Even though it is given as x, it is not varying, it is not a variable. Only thing that is variable here is dl. So dl you are taking here, you can take here, you can take here, you can take dl for all small parts along the circle. So the dl is the only variable, and if you add all the dl's, basically dl means addition, integration means addition. So what you are doing, you are taking small parts of the circle and then you are adding them. Right, small parts of the circle and entire circle, a complete circle, right? So this will be a closed integral. So complete circle means basically it is the perimeter of the circle. So you are taking small portion of the circle and you are adding them, so you are getting the total perimeter of the circle. So mu naught by 4 pi, okay, IR by r square plus x square to the power 3 by 2 into square root to close integral dl, that is 2 pi r. Okay, 2 pi r, so you can cancel here, so you will get mu naught by 2 pi. Okay, let me write it here. So you get mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. Okay, this is the formula. This is the formula field at a point on the axis of the circular loop. So this is the formula. This is, if you derive up to this point, you will get full marks. But if they add one more small part, that hence find the magnetic field at the center. Magnetic field at the center, Bx center, is when x equals to 0. That is equals to mu naught. So at the center means you are finding here, that means this x distance becomes 0, right? If you put x equals to 0, you will get the magnetic field at the center, mu naught by 2 into I r square. Okay, x becomes 0, so it will r square to the power 3 by 2, r square to the power 3 by 2, so multiply, so it will be r cube, right? So r square by r cube, and as you can see this will cancel, so you will get I by r, mu naught by 2 I by r. This is an important formula. Okay, especially if you are preparing for KCET exam, then this formula has to be remembered. Also for derivation, they might give you at 1 mark extra, so total derivation is 4 marks, and they can add this extra derivation for 1 extra marks. Okay, so be careful, in case they ask you, you have to know how to do that. Okay, now let's move on. 40A, two coherent waves of constant phase difference undergo interference. Obtain the expression for the resultant displacement. Write the conditions for constructive and destructive interference in terms of phase difference. Very interesting. First of all, 4A, 40A, not super common, but we know we can derive that y1 equals to, let us consider two waves. Y1 is equal to A sine omega t and y2 equals to A sine omega t plus phi. These are the two waves. So what is the meaning of that? So two waves means we have to take two waves. They are interfering waves. You can take in any form. This is the easiest form to take. So y1 is equal to A sine omega t. That is the first disturbance, and the second disturbance is y2 is equal to A sine omega t plus phi. Okay, so this is the constant phase difference. So what is the total phase? Total wave will be, after they interfere, total wave will be simply addition, right? So A will be common, sine omega t plus sine omega t plus phi. Okay, I think it is 3 plus 2. So this derivation is 3, this derivation is 2, this much is 2. Okay, so now sine C plus sine D, what is the formula? 2 into cos omega t minus omega t plus phi by 2 into cos. So sine C plus sine D, that is 2 sine omega t plus phi by 2 into cos omega t minus omega t plus phi divided by 2, right? This is the formula, we all know that. Now let's simplify. A 2A, let's take this 2 outside, right? So sine it will be omega t plus omega t 2 omega t plus so it will be omega t plus 5 by 2, okay, into cos omega t will cancel, so it will be 5 by 2, or you can say it will be 2a cos 5 by 2 into sine omega t plus 5 by 2, right? So this is the new amplitude. So whatever is after the waves interfere, the new amplitude of the wave is given by this. So initially the amplitude has no cos or sine term in it, but after they interfere, the amplitude now has a cos phi. Why cos phi term? Why we are not including this term? Because it has a time dependent term, whereas cos phi by 2 is the, because phase difference is fixed, it is basically a constant. Okay, cos phi by 2 is a constant. Depending upon whatever is the phase difference, it can have different values, but for a given phase difference, this is a constant. Now they have said that expression for the resultant displacement. So this is the expression for the resultant displacement. As simple as that. Now if they ask you the expression for resultant intensity, so intensity is basically proportional to amplitude ka square. So here amplitude is basically 2a cos phi by 2, so intensity will be equals to 2a cos phi by 2 whole square, okay. So or you can write this as 4a square cos phi by 2. Now it is all of them are proportional relation, not equal. There is a proportionality relation, because intensity is not exactly equals to, there is a proportional value, constant we do not know, but what we know that initially both the waves have same intensity. What was that? Both waves had same intensity, say I naught was both for both the waves was proportional to a square, right? So this wave was also amplitude A, this was also amplitude A, so both cases had proportional to a square. Now a proportionality constant will be same, whatever proportionality constant here, the same proportionality constant will be here. So you can say that I is equal to 4 I naught cos square phi by 2. So this is the expression for intensity. This is extra, this is not asked in this question, so you can but if they ask you and hence find the expression for intensity, you have to know what to do. Okay, you can directly do I by I naught. So if you do that I by I naught, directly you can, the a square will be cancelled. Okay, so that is one of the way. Anyway, now let's see what is the condition for maximum constructive interference. So phase difference, in terms of phase difference, constructive interference is when it is equals to n lambda, okay, where so the phase difference for constructive interference is 2 pi n, okay, n is equals to 0 1 2 dot dot dot, okay. So this is the condition for constructive interference, that is even multiple of n. So if it is 0 2 pi 3 pi, then it is basically giving you constructive interference, and if it is an odd multiple of pi, then you are getting destructive interference. So you can write it like this, 2 it will be odd multiple, right? So it will be n plus 2n plus 1 into pi. So if it is 2n plus 1 into pi, where n equals to again 0 1 2 3, then you will get a destructive interference. This is the condition for constructive interference, this is the condition for destructive interference in terms of phase difference. Now let's move on to the next question. What is a rectifier? Explain the working of a full wave rectifier using a neat circuit diagram. Draw this input output waveforms. Very important question. Okay, let's see. A rectifier is an electronic device that converts alternating current AC into direct current DC. Okay, positive half cycle of AC input. During the positive half cycle of the AC input, the voltage, the upper half of the transformer secondary winding becomes positive, diode D1 becomes, so let's see the diagram. So this is the diagram, this is the easiest diagram given in your textbook. So in the positive half cycle means when the current is increasing. Okay, in that case your first part becomes positive and the bottom part becomes negative. Right, so this is how you can find the AC circuit, right? So first diode D1 is conducting when this is positive. The diode D2 will conduct when the circuit is becoming negative. Okay, so first half cycle, that is first half cycle means you can divide the circuit into two different halves. Okay, first half cycle, as it is a AC can be divided into two halves like this. Okay, so first half it is positive, second half it is negative. So first half cycle is, this one is called first half cycle, this one is called second half cycle. Okay, in the first half cycle, diode D1 becomes forward biased and conducts. So at this point this is positive, this is negative, and again if you consider this one, then this one is positive, this one is negative. So diode D1 conducts, diode D2 does not conduct. So only one way to flow the current, right? So only one way to flow the current. Now because of this, you can say that the diode D1 is conducting, diode D2 is not conducting. But when it is conducting, the current is flowing through this RL. Right, so current is flowing through RL. Now in the negative half cycle, this part becomes positive, this part becomes negative. Again the current can only flow in this direction only. So again the current is flowing through this XL in the same direction. No matter the current direction changes, but the current flowing through RL remains the same direction, right? Let's see. So in the negative half cycle of the AC input voltage, the lower half of the transformer secondary winding becomes positive, diode D2 becomes forward biased and conducts, while diode D1 is reverse biased and does not conduct. Current again flows through the load resistance RL in the same direction. This is very important. You have to mention that to get the full marks. Okay, same direction as during the positive half cycle. Okay, now this is the answer to this question. Okay, and this is the diagram that you have to draw. Input cycle. Okay, wavefront at A, so point A, wavefront is this, wavefront at B, this is the wavefront for B, and what is the output you are getting? This is the output that you are getting. So for all the total wave, you are getting a full wave rectifier. This is why it is called full wave rectifier. So all the currents, initially you see current was varying, right? From the point of view of A or point of view of B, and the waveform was varying, but after it is rectified, as you can see, it is only one sided. Even though it is fluctuating, the voltage is fluctuating, but all the currents are in the same direction, right? That is why it is called DC form, right? Now next is numerical question. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 cm away. Obtain the work done in the moving a charge of 2 nanocoulomb from infinity to the point P. Does the answer depend on the path along which the charge is moved? So first of all, we have a 400 nanocoulomb charge at some point. Say A. The charge is 400 nanocoulomb. And we are trying to find the potential at a point 9 cm away from it. So the distance is 9 cm. 9 cm can be written as 9 into 10 to the power of minus 2 meters. I always prefer using this method. If you are comfortable with decimal approach, you can use decimals as well. Okay, so this is the point where we are trying to calculate the potential. So potential, what is the formula for potential? Formula for electric potential is very easy. K Q by R. This is R. Okay, K is 9 into 10 to the power of 9. Okay, this is like, as I mentioned, this is like the Tika. Okay, that you have to always apply. And Q is basically the charge, 400 nanocoulomb. 400 nanocoulomb means 10 to the power of minus 9 coulomb. Okay, if you can show the conversion at the beginning of the problem. So what you have to do? You have to do Q is equal to 400 nanocoulomb. Okay, so you have to write 400 into 10 to the power of minus 9 coulomb. R is 9 centimeter, okay, or is equal to 9 into 10 to the power of minus 2 meters. If you can show them, it will be very, very good. Okay, 9 into 10 to the power of minus 2. Now 9 cancels, 10 to the power of plus 9, 10 to the power of minus 9 cancels. So voltage will become 400, and this will come up, it will become 10 to the power square. So it will be 4 into 10 to the power of 4 volts. This is the potential. Unit is easy, volt. We are trying to find potential. Potential's unit is volt, right? Now part B. Obtain the work done in moving a charge 2 nanocoulomb from infinity to that point P. So work done is basically given by Q into V. Work done is given by Q into V. So potential is defined by work done per unit charge. So here we are trying to find total work done. Total work done is basically nothing but this is the Q dash. So Q dash is the test charge. So Q dash is 2 nanocoulomb. So 2 nanocoulomb means 2 into 10 to the power of minus 9 into V. V is 4 into 10 to the power of plus 4. Right, plus 4, right? Yes. So it will be 8 into 10 to the power of minus 5 joules, or you can say 80 microjoules. Okay, so 80 microjoules is the answer. You can leave the answer here or here, your choice. No, you will get full marks. Now this is the work done. Now this work done is independent of the path, as it only depends on the final and initial and final point. It is independent of the path taken. It is a conservative force. Electric force is a electric field is a conservative field, so it is independent of the path taken. You have to mention electric field is a conservative field. That's why it is independent of the path taken. Right, now let's move on to the next question. Okay, this is also from interesting question. Let's see. In the following network, find the current I3. So we are trying to find I3. I3 is this current, right? How to solve it? They have already done the KCL part, that is the current division part is already done in the circuit. So the current, suppose the total current I is entering the circuit, that I is given as 1 ampere, right? So 1 ampere current is entering this junction, and it is dividing into two parts, I1 and I2. Now this I1 is traveling along this path, and then it is again dividing into two parts. One is I3, another is I1 minus I3. Obviously that is the KCL. Again I2 is coming from here, it is collecting I3, so it is now I2 plus I3. Okay, and again they are merging here, so total current is again I1 plus I2, that is that is equals to 1 ampere. So this is the basic circuit. We have to find this I3. How to do that? If you observe, this battery is not given, so you might think, okay, this might be an incomplete question, so if I just attempt it, I will get full marks. No, battery is not required, the voltage is not required. Current, total current in the circuit given, that is sufficient to solve this question. So we will consider two loops, say 1, 2, 3, 4, 5. Okay, and then 3, 5, 6, 7. These two loops we will consider. First we will consider this loop, next we will consider this loop, and we will apply Kirchhoff's voltage law, okay, or Kirchhoff's loop rule, whatever you say, whatever you are comfortable with, and based on that we will try to find. Now if you see in these both loops individually, if you consider this loop or if you consider this loop, okay, there is no battery attached to this. That means on the right hand side it will be 0. Okay, so no external batteries attached to this individual loops, so the entire thing will be 0. Now what all we can write from this point? So current entering is I, that is equals to 1 ampere. So first we can write first equation, I1 plus I2 equals to 1. Right, the current total current in the circuit is 1 ampere, and that is divided into two parts. So I1 plus I2 is equal to 1, and from there let me write the value of I2. We will use that in later part. I2 is equal to 1 minus I1. Okay, you can do the other way also, I1 is equal to 1 minus I2, but let use this simple as that. So this is the first part that we have to write. This is equation 1. Now let us consider the loop 1 2 3 4 5 1. Okay, one loop 1 2 3 4 5 1. So if you remember that whenever we are writing a loop, we have to start from a point and we have to end at the same point. That is why this 1 is coming 2 times. Okay, this is a way to remember. You can use A B C D E F G H, that is fine. I am using the numbers, that is also okay. Whenever you are solving this, you have to draw the same diagram in your answer sheet for the teacher to able to understand, okay, whether you are solving it yourself or you have copied it from someone else. Okay, if you don't draw the diagram in your notebook, maybe teacher can deduct some marks. So from loop 1 2 3 4 5 1, we can write first what is the first resistance. So we are starting here from 1 to 2, nothing is there. From 2 to 3, there is a resistance of 10 ohm. The current is I1, so 10 I1. Okay, next from 3 to 4 we have another resistance which is 5 ohm. Now what is the direction of current? Direction of current is in the same direction where we are going. We started here, we are moving. Okay, if we go in the direction of current, it will be positive. If we go opposite to the direction of current, it will be negative, right? So here in case of I1, we moved in the direction of current. That is why it is positive. Again, from 3 to 4 also, we are moving in the direction of current only. So again, it will be positive. So it will be plus 5 I3. Now for this resistance, now we are traveling in the direction here, right? And the current is passing in this direction. So while we are closing the loop, basically this time we are going opposite direction of the current. So we can write minus 20 I2 equals to 0. Okay, this is the thing. Now if you see, 5 is common in all the terms, so let's take 5 common. On our right hand side we have 0, so we can simply eliminate that 5. So 5, if we take 5 common, 2I1 plus I3 minus 4I2 equals to 0. So this 5 can go away because this is not 0. On our right hand side we have 0. So 2I1 plus I3 minus 4I2 should be equals to 0. Right? Clear? So this is what we have done. So you can take that 5 common and make that part disappear. Now what we have to do, this is not done. We have to put at least reduce these variables, right? Here we have 3 variables. We cannot have 3 variables. It is difficult to solve having 3 variables. We have to reduce it. So how to do that? We know this relationship. So 1 minus I1, that is equals to 0. Now break it. 2I1 plus I3 minus 4 plus 4I1 equals to 0. So now let's organize it. 4 plus 2, that is 6I1 plus I3. Now this minus 4, we can take it on the other side, it will become 4. So this is equation 2. Okay, so this is the equation 2. Now similarly we will apply the KVL on this part and we will find the equation 3. So what is the loop? 3 6 7 4 3. 3 6 7 4 3. So first so in the direction of current is going in this direction, 10 into I1 minus I3. So 10 I1 minus I3 into 10. Okay, 10 into I1 minus I3. Then this is in the direction of current. Now when we are traveling in this case, here we are traveling in the opposite direction of the current. So 5 into I1 I2 plus I3. Now it will be negative. Why negative? Because we are traveling in the opposite direction of the current. I2 plus I3. Now from 4 we are traveling again in this direction. So again in this direction, as we can see, it is going we are going opposite direction of the current. So minus 5 I3, and no battery is connected, so it will be 0. Okay, you have to practice this. Again we can take 5 common and cancel that 5, so it will be 2i1 minus i3 minus 5 is gone, i2 plus i3 and minus i3, that should be equals to 0. Okay, so now what we will do, let me reduce the equation. I cannot keep all the equations on board, so I will only have to keep the required equation for the solution. Okay, you will get the PDF once it is solved, but unfortunately you have to check the entire solution video to get the idea why it is like this. Okay, so that will give you, so this is equation 2. Okay, now I have some space to solve. So this is the part. So now 2i1 minus 2i3, right, 2i1 minus 2i3 minus i2 minus i3 minus i3, that should be equals to 0. So what is the thing we get? 2i1 minus i2 minus 2, 3, 4 minus 4 i3 equals to 0. Again i2 we have to replace i2 with 1 minus i1, right? So replace it and try to find. Now we will have a 2 variable equation, 2 equations with 2 variables. We just need to eliminate and solve the unknown i3. Okay, so this is our strategy. So let's put 2i1 minus i2 is 1 minus i1. Okay, minus 4i3, that is equals to 0, or 2i1 minus 1 plus i1 minus 4i3 equals to 0. So now this one will go on the right hand side, so you can write 3i1, 2i1 plus i1, 3i1, okay, plus 4i3 equals to 1. So this is equation number 3. Okay, so equation number 3 we have found. What is our equation 3? 3i1 plus 4i3 equals to 1. This is our equation 3. Now it is simple. Sorry, am I right? No, I am not right. This will be negative, right? Why negative? Here it was negative sign. Somehow that was missed and I made some mistake, and final answer would have been wrong, and you will say, sir, you have not done it correctly. It is not matching, right? So don't worry, your final answer will be correct. Let's see. So now we have to eliminate what? I1, right? I3 we are trying to find. So to eliminate I1, what we have to do? If we multiply this equation 3 with 2, so equation 2 with 1 minus equation 3 with 2, then we can eliminate I1. So this is 6, this is 3, right? So 3 2s are 6. So if we multiply this with 2 and subtract, then we can eliminate. So first let us write first equation, 6i1 plus i3 equals to 4. Next is multiply this with 2, so 6i1 minus 8i3 equals to 2. So minus plus minus, so this cancels, you get 9i3 equals to 2, or i3 equals to 2 by 9 amperes. So this is the answer for this question. Okay, you have to use a step-by-step approach. Obviously this is a long solution, a long numerical. That is why in my personal opinion I do not recommend current electricity for numerical questions, even though answers are doable, but it is a longer answer. Okay, if you are super confident and if you are someone who is preparing for KCET or JEE for a long time, definitely this is a go-to for you. You can answer such questions. Otherwise my recommendation is electrostatic potential and capacitance. We have already seen one question from capacitance chapter, right? Easy question. Electric field might be there also, and AC chapter. Okay, let's see, this is an AC chapter. You have to answer only 2 numerical questions, right? An AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistor of 100 ohm. Does the current lead or lags the voltage? Calculate the phase difference between the current and the voltage. Okay, so first what we have to do, let's see what all are given. We have a L, we have a C, we have a R, LCR, series LCR circuit, AC voltage 50 Hz, voltage is not given but frequency is given, which is important. L is 1 Henry, C is 90 microfarad and resistance is 100 ohm. How to start? First we have to calculate the two brothers XL and XC. What is XL? XL is 2 pi f L, right? This is the XL, inductive reactance. So 2 pi, now I don't have the calculator, so definitely I will not be able to calculate the exact value. So it will be 100 pi, which is equivalent to 314 ohm. Okay, this is XL. XL was easy, even without calculator you can solve it. Now what is XC? XC is 1 by 2 pi FC. Okay, right? So one is normal, one is 1 by. Okay, two brothers, they are always fighting with each other. One is saying I am bigger, another one saying no, I am bigger. So one determines whether current lags or current leads. Okay, so this is what. So if XL is greater than XC, then current will be lagging. If XC is greater than XL, then current will be leading. As simple as that. So 2 pi into 50, C is 90 microfarad. 90 microfarad means what? Micro means 10 to the power of minus 6. Now 10 to the power of minus 6 in the division, it will go up and it will become 10 to the power of plus 6 in the numerator, right? So now let's multiply. 2 pi is 100 pi, 10 to the power of 6 divided by 100 pi into 90. Now let's cancel the zeros. It will be 1000 divided by 9 pi, right? It will be 1 2 3 zeros cancel. 3 0 cancel means 10 to the power of 3. 10 to the power of 3 means 1000, and in the denominator we have 9 and we have pi. Okay, so what is the exact value? I think it will be less than XL. Okay, it is about approximately 3 9s are 27. 27, 1000 divided by 27, it will be approximately 35 approximate. Exact value you can calculate. Okay, what is I am thinking is 35 ohm. You can use the calculators in your board exam, normal regular calculator, so you can use that to calculate XC. Now you can see that XL, in the tug of war between XL and XC, XL is the heavier one. So XL is heavier one means XL is greater than XC. So current will lag the voltage. Current lags the voltage. So if the circuit is, in the circuit if XL is greater, current will lag. In the circuit if it's, XC is greater, current will lead. Simple, very simple concept. Equations are also very limited, only few equations you have to use, and 90% of the problems are based on XL, XC only, right? In some cases they will ask you resonance, but everything is linked. All the formulas in this chapter, all the numerical questions from this chapter are linked. So basically you can solve this easily. That is why it is one of my recommended chapter for even weaker students can solve it. You have to practice 5-6 questions, 5 or 6 questions repeatedly, then definitely you can solve all such questions. Okay, now next is, does the current leads or lag the voltage? So we have calculated current lags the voltage. Now calculate the phase difference between the current and the voltage. So phase difference tan phi is basically XL minus XC divided by R. This is the phase difference. Again, I cannot calculate the exact value. 314 minus 35 divided by 100. Okay, you can calculate it. 295, I think. 15 is 15 cancels, 20, 280. Approximately 279 divided by 100. So it will be 2.79. Now you can leave the answer here, tan inverse 2.79, because scientific calculators are not allowed. If you know the answer, you can put the values as well. Okay, so this is the answer for phi, and this is the way to solve this question. Easy question. As you can see, we have not wasted too long time like we did in the last question, right? Now last question of this chapter. This is also one of my recommended chapter for alternative questions in case the question is difficult, question paper is difficult. This is the chapter from ray optics. An equilateral prism is made of glass of unknown refractive index. Okay, a parallel beam of light is incident on the face of the prism. The angle of minimum deviation is 40 degrees. Find the refractive index of the material of the prism. If the prism is placed in water of refractive index 1.33, find the new angle of minimum deviation of a parallel beam of light. Okay, so first what is there is a parallel beam of light. Ignore about the parallel beam of light, that they're parallel or not. The most important thing is equilateral triangle, and angle of minimum deviation is 40. So angle of prism is 60 degrees. Equilateral prism means angle of prism is 60 degrees and minimum deviation is 40 degrees. We are only interested in these two values. So what is the refractive index? Refractive index is sin A plus delta m by 2 divided by sin A by 2. Again, this requires some sort of calculator to calculate, because 60 plus 40 is 100, divided by 2 is 50. So this is not a standard value. Sin A by 2 is 60 by 2. We can take this close to 45, and we can assume it will be close to 45, but that will be an approximation, not exact value. Okay, sin 30 degrees. Okay, now you can use your calculator to calculate the exact value of sin 50 degrees, right? I think it will be approximately 4 by 5. Okay, approximate value. Since I'll have to do approximation, I will take the approximated value 4 by 5. Okay, why it is 4 by 5? Because I know that sin 53 degrees is basically 4 by 5. This is known to me. I am just using that knowledge to calculate. Now sin 30 is 1 by root 2, right? So it will be 4 root 2 by 5. Okay, so this will be the approximate value. Obviously 1 point something will be the answer, but this is the refractive index. Okay, you can use the calculator to calculate the value. So see, in your board exam, in case they are giving you some unknown values, they will give you such a way that you can at least use your calculator to calculate those values. If they are giving values which are not very efficient, then you can leave it like this, you will get full marks. Don't worry. Okay, the approach is correct, has to be correct. In case the final answer does not match, they might deduct 1 mark, but 4 marks is better than 0 marks, right? So Next is find the refractive index of the material of the prism. So this is the refractive index of the material of the prism. Next is if the prism is placed in water of refractive index 1.33, what is the new angle of minimum deviation for the parallel beam of light? So when the prism is placed inside water of refractive index 1.33, the relative refractive index of the prism with respect to the water is given by refractive index of the prism. So this is the refractive index of the prism, okay, divided by the refractive index of the surrounding medium, that is refractive index of the water. So 4 root 2 by 5 divided by 1.33, and same formula. So we are using the same formula, only thing is that delta m is unknown. So a plus delta m by 2, a we know, delta m we don't know. In the denominator it will be a by 2, that is 30 degrees. Okay, so you can say sine a plus delta m by 2, okay, is equals to 4 root 2 by 5. Now 1.33 can be written as 4 by 3. Okay, this is another way, and 1 by root 2 is multiplied. So sine 30 is 1 by root 2. So 1 by root 2 cancels. Okay, you can see this 4 is also cancelled. So it will go up and you will get 3 by 5. It will be 3 by 5. Now we know that what is 3 by 5? 3 by 5 is again sine 37 degrees. Okay, so sine a plus delta m by 2 equals to sine 37 degrees. So 3 by 5 and 4 by 5 are known values. So from here you can say a plus delta m by 2 is equal to 37. Now this is not exact calculation, we did a cheating here. What cheating we did? We assume that 50 degree is very close to 53 degrees. That is why the answer is coming so good. Okay, in your board exam the values will be given such that either 53 will be coming over here or some known values will be coming, so that you can do the approximation quickly or you can calculate them quickly, because scientific calculators are not allowed in your board exam. So a plus delta m is 74. Okay, so delta m is 74 minus 60. Why 60? A is given 60, so it will be 14 degrees. Now this is an approximated value. Okay, you can use your exact calculator to find the exact value, but even though we have approximated by small amount, our result is free of any calculator problem. So we have solved this numerical as well. So this is the last question of this model question paper. I will be solving other two model question paper very soon. Okay, so if you have not yet subscribed to our channel, don't forget to subscribe to our channel and give it a like. I'll be back. Till then, bye.